So volume of a cylinder. The volume of a cylinder is a product of the area of the base and the height of the cylinder. So when we translate this into a formula, we're going to get V equals BH. And it's always going to be labeled as V, big V equals big B and little h. And we can look at the diagram here, and it says the area of the base is big B and the height is h. So let's look at this example here as to how to solve for the volume of the cylinder. Okay. So we're going to follow the basic formula that we looked at here of big V equals big B times h, volume equals base times height. And we're going to go ahead and substitute it in. So looking at our picture here, we notice that the base of a cylinder is a circle. And the formula to solve for this is pi r squared, right? So we're going to go ahead and put in, let me make that a bit more clear. The formula to solve for the area of the base, in this case the circle, would be pi r squared. So we're going to put pi r squared here, and we're going to multiply that by the height, which is 6. So when we substitute everything in, we're going to get pi times 3 squared times 6. The 3 is because the radius is 3, and that's given to us. And when we go ahead and simplify and expand, we're going to get 54 pi. And then you're going to go ahead and just multiply that out with pi equaling 3.14. And then you're going to get about 169.6 cubic meters. So you always want to read the directions when you're working with these types of problems, because sometimes it might ask you to round or multiply out 3.14, and sometimes the problem might just ask you to leave it as pi. So did that make sense for everyone? Okay, I'm going to assume that made sense. Let's go to the next slide. Okay, now we're going to find the height of the cylinder. To find the height of the cylinder, we're going to still be using the same formula that we had here, because in this case we're already given the volume of the cylinder. So once again, we're going to substitute the information that we are given back into this formula here, which would be volume equals base times height. In this case, we're already given the volume, and if you look carefully, we are given part of the area. So if the diameter is 10, then the radius is divided by 2. So 2 times radius would equal diameter. So using that information, we can go ahead and divide 10 by 2, and we find out that this part is 5 and this part is 5. That means the radius is 5. We're going to substitute the radius into our equation as well, and then we're left with 314, the volume, equals pi times 5 squared times h. And as you may notice, we have h as our variable here, and the variable we're solving for, because in this case we're looking for the height, not the volume. And we're going to go ahead and simplify, expand, and you're left with 314 equals 25 pi h. And then we're going to divide by 25, and 25 times 3.14 on both sides, and we're left with about 4 inches. So the height of this specific cylinder here is about 4 inches. Do you guys have any questions relating to finding the height of the cylinder or finding the volume of the cylinder? Okay. Let's go to the next slide. Now we're going to be looking at volume of cones. And so in this chapter, you'll learn how to find the volume of a cone and find the height of a cone. Okay. So to find the volume of a cone, you have to take 1/3 of the product of the area. Okay, the volume of a cone is 1/3 of the product of the area and of the base and the height of the cone. So if we look at the formula, that would be volume equals 1/3 times base times height. So this is similar to a cylinder, except a cone is only 1/3 of a cylinder. So we're going to have to multiply in 1/3 to our volume formula. Okay, let's take a look at this example here. To find the volume of the cone, we're going to be using this formula and we're going to substitute. So based off of the picture, we know that the height is 6 meters and the radius would be 2. Because once again, we know the diameter. They give us the diameter. And from the diameter, we have to find the radius. And the radius is 1/2 of the diameter. So 4 divided by 2 would equal 2. So the radius is 2. And now we're going to substitute that back in. Since to find the area of the base, the formula for the area of the base in this case would be pi r squared. So we're going to substitute into that equation. So 1/3 times pi r squared times height would equal 1/3 pi times 2 squared times 6. And we're going to expand and simplify, and we're left with 8 pi, which is about 25.1 cubic meters. Okay. Let's look at the height of cones now. Once again, similar to what we did with the cylinders, we're going to be using the same formula that we found to solve for the volume of the cone, except this time we're finding the height and plugging in the information we were given. So this time we're already given the volume of the cone. So we're going to substitute that back into our equation here, and we're left with 956 equals 1/3 BH. And if we look here, we are already given part of the area of the base, and we know the radius here is 9, looking at the picture. So we're going to plug 9 into our formula, and we're left with 956 equals 1/3 pi 9 squared times h. Simplify, 956 equals 27 pi h. Since we're solving for height, we're going to go ahead and divide 27 times pi onto both sides. And we're left with h equaling about 11.3 feet. Okay. Volume of spheres. Oh, that's supposed to say sphere over there. Let me go ahead and fix it really fast. Volume of a sphere. The volume of a sphere is the product of 4/3 pi and the cube of the radius of the sphere. So this formula gets a little bit more complex, and we're going to solve. The formula would be volume equals 4/3 r cubed. So you always have to remember that the radius is cubed. Okay, let's take a look at this example here. We're going to find the volume of the sphere. So the volume equals 4/3 pi r cubed. And we're going to go ahead and substitute the information we are given. In this case, we're given what the radius is. So we're going to substitute that in, and we're going to get 4/3 pi times 4 cubed. When we expand this, we are left with 256 divided by 3 times pi. When we simplify and multiply out 3.14, we're left with about 268.1 centimeters cubed. You're always going to have cubic units when you're solving for volume because we're doing three. You're going to have a width, a length, and a height. So let me go ahead and okay. Let's go on to our next slide. Okay, now we're going to be finding the radius. Okay, so we're still using the same formula for volume. Volume equals 4/3 pi r cubed. And we're already given the volume and it's equivalent to 288 pi. So we're going to substitute that in. 288 pi equals 4/3 pi r cubed. And in this case, we're going to multiply out and then simplify it, and we're left with 216 equals r. And then, okay, that's not right. Let's see what happened there. R should be equivalent to, R should equal 6. So the radius equals 6 inches. Okay. Okay, now we're going to be finding surface area and volumes of similar solids. So we're going to be identifying similar solids, find missing measures in similar solids, finding surface area, and also finding volume. Okay. Okay. So now we're going to be comparing different cylinders and trying to figure out which one of these are proportional. Okay. So we're going to first be comparing cylinder A and cylinder B. So if you look over to the right here, we have the pictures of the different cylinders. The purple is cylinder B, the blue is cylinder C, and the green one is cylinder A. So first we're looking at cylinder A and cylinder B. So we're going to be comparing the heights and the radius. Okay. So the height of A would be 4, and we find that from the picture here. And the height of cylinder B is 3, so that's 4/3. And the radius of cylinder A is 6, and the radius of cylinder B is 5. So these are not proportional, as we can tell, because they don't equal each other. All right, now we're going to be looking at cylinder A and cylinder C. So let's compare these two. The height of cylinder A is 4 centimeters, and the height of cylinder C is 5 centimeters. Or meters, sorry about that. Okay, and then the radius of cylinder A is 6 meters, and the radius of C is 7.5. So once you simplify it all the way down, eventually both of these equal each other. So that means they are proportional. Okay. So cylinder C is similar to cylinder A. I'm not going to go really into depth about simplifying these two down because it does get a little complicated with all the numbers, and so we're just going to say they're proportional right about here. Okay, So now we're going to be finding missing measures in similar solids. So in this case, they already tell us that the cones are similar, which means they have to equal each other and they are proportional. So what we're going to do is we're going to use this basic formula here to compare cone X and cone Y. So first we're going to be looking at radius of X. So the radius of X divided by the radius of Y should equal the slant height of X divided by slant height of Y. So we're going to substitute using the information we are given from the picture. And so the radius of X would be 5. We're going to plug that in. The radius of Y would be 7. We're going to plug that one in there. And this is all equivalent to 13 over L. How do we know that it's equivalent to 13 over L? Because the slant height of cone X is 13, and the slant height of cone Y is L. So if we reread the question here, we're solving for the slant height L. So that probably means we want to isolate this variable. And to do so, we're going to do cross products property, which is just a fancy way of saying that we're going to multiply 7 to the right side and L to the left side, so we don't have any denominators in our equation here. So once we do that, we are left with 5L equals 91. And now we're going to divide each side by 5 so that we can have L isolated. And once we do that, we are left with L equals 18.2 yards. So that means the slant height of cone Y is 18.2 yards. So was everybody able to understand that, or do we have any questions regarding that? No? Okay. Okay. So now we're going to be finding the surface area. So the surface area is pretty much going to be saying how much, we're just adding all of the areas that are visible on the outside of the shape. Okay, so we're going to be using this formula here, surface area of A over surface area of pyramid B equals the height of pyramid A and over the height of pyramid B, and these are all squared. So both of these should be squared. So just to clarify, the square applies to both the height of pyramid A and the height of pyramid B. So we're going to go ahead and substitute based on the information we know from this picture here, and we are left with surface area, because we don't know the surface area for pyramid A yet. So we're going to put surface area over 600, because we are given that the surface area of pyramid B is 600, equals the height of pyramid A squared, which is 6 squared, over the height of pyramid B squared, which should be 10 squared. And we're going to evaluate, and we're left with surface area of pyramid A over 600 equals 36 over 100. So we're going to use the multiplication property of equality to get rid of the denominators. So to do that, we're multiplying by 600 to both sides. Since in this case 600 is divisible by 100. And then we're left with S equals 216. So the surface area of pyramid A is 216 square feet. Did that make sense? If you guys have any questions, just feel free to ask. You can either ask in the chat or you can unmute yourself and just ask. Also, if I'm going too fast or too slow, you guys can let me know and I will adjust my pacing according to that. Okay. All right. Okay. So now we're going to be finding the volume of just like the volume of simple figures. So we're going to be looking at this here first. I feel like I skipped a slide. Hold on. Okay. Looks like we're on track. So the dimensions of the touch tank at an aquarium are doubled. What is the volume of the new touch tank? So we're given a few options here. We have option A, which is 150 cubic feet, option B, which is 4,000 cubic feet, option C, 8,000 cubic feet, or option D, which is 16,000 cubic feet. So the dimensions are doubled, since we found that out from the problem here. The dimensions are doubled, so the ratio of the dimensions of the original tank to the dimensions of the new tank would be 1 to 2. So from what we know from the problem and from the picture here, we have this formula set up here, which is original volume over new volume equals the original dimension cubed over the new dimension cubed. And we're going to substitute, and that would give us 2,000 over volume over the new volume equals 1 cubed over 3 cubed. We're going to simplify, and we're left with 200 over the new volume equals 1/8. Now we're going to get rid of the denominators by multiplying out. We're going to multiply the left side by 8 and the right side by v, and we're left with 1,600 equals v. So the new volume of the tank is 16,000 cubic feet. And to double check, we can look at our answers here, and that was one of our answers, so we're correct. So the correct answer would be D, 16,000 cubic feet. All right. So do you guys have any questions about anything we learned? Okay. Well, we were only supposed to go over chapter 8 today, so that's really all we had planned. Let's see. Do you guys want to do a couple of practice problems together?
No, I think it's fine.
You want to do a couple of practice problems?
No, it's fine.
No? Okay. Well, that was a really short class then, because that was only 25 minutes. So,
Does that mean class is over already?
no. How about let's do a couple practice problems. I think that would be good. Okay.
Okay.
Yes. So let me pull up a couple practice problems for us. Okay. So we will be, just a quick heads up for all of you guys, we will be giving you guys a little pop quiz sometime next week or the week after. So if you guys have any questions from previous lessons that we did, you can go ahead and ask them now, and then I can go over them really fast.
Will you post like all the slides for like extra study and more revision?
Are they not already posted on Google Classroom?
Like will you post like this one and the other and